Hi everyone. We will start with the next talk, elevating edX development, the Repo Health Dashboard Unveiled, given by Muhammad Saban Javed. Enjoy the talk.
Thank you. Hi everyone, good evening. First of all, so sorry I couldn't join you guys over there, but unfortunately I wasn't able to get my visa on time. So luckily my team members are there present with you, so if you have any questions or concern during the talk, then you can always stop and ask your questions, or you can wait for the QA session at the end of the talk and then present your questions. So without further ado, let's dig into the talk. First of all, I am Usama Sadiq, and along with me is Sovan Javed. So both of us are Resource employees, and we have been working with the OpenEdX ecosystem for the past 5 years now. And over the years, we have worked on some major infrastructure upgrades like Python and Django, starting from back then when Python 2.7 to 3.8 and now 3.12, and along with the Django 1.11 to Django 4.2 upgrades. Other than that, we have also worked on upgrading the infrastructure changes, upgrading infrastructure in the OpenEdX codebase, like migrating the CI, especially from Travis and Jenkins to use GitHub Actions instead. And recently, we have worked on migrating the Ansible-based images to Docker-based images. So we have been pretty much busy with the infrastructure changes around the OpenEdX ecosystem. So let's dig into the agenda. So we'll be discussing our problem, which issues we were facing, why we needed to build a new solution, and how it benefited us to use this custom-made solution, and how its technicalities are being implemented, and what's in it for the community. So first of all, what problem we were facing. So as you all know, OpenEdX has a very large code base, and it has we were responsible for managing around 120 plus repositories, which were present across edX and OpenEdX organizations. And one of the major concern was we wanted all the repos and all the packages to follow the specific standards set by the community, just like OIL 18 and other quality standards checks as well, and which was not possible if we were not tracking all the repos consecutively. And similarly, one another major issue that we face is the dependency management in multiple repos. So we have around 8 plus services in OpenEdX ecosystem, and we have the rest of them are the packages. But each Django repository or each Python or Django repository has its dependencies, which need to be updated on a regular basis. But if we need to identify which dependency is being used in which of the repos, then there wasn't an easy way instead of the GitHub search and listing down them manually. So that was one of the concerns. Other than that, we wanted all the repos to be compliant with our security standards, and all the packages to have the latest security supports. Especially when doing the Python and Django version upgrades, we faced a lot of issues because we needed to implement the upgrade across all the repositories, but there wasn't any standard way to track our upgrade efforts and track the milestones of how much upgrade we have completed and each of the repos have been left. So that was very headache for us, a very big headache for us. Especially when implementing the testing standards, we wanted to know if which of the repos have implemented the test or not, which repos have the coverage checks or not, if they have been using the quality checks or not. So those were some of the issues that we wanted to address while building a specific solution for that. So what started as an in-house simple check was converted into another big solution for us. And since that was used to monitor the health of our whole OpenEdX code base, so we named it as Repo Health Dashboard 2. We made it to monitor our code base, so it helped us in noticing and improving our quality, our dependency management systems, and especially in meeting all the compliance standards and all the repos. So the key features for tool are just like I mentioned in finance analysis, and we can identify the background checks or not, we can identify which securities are being needed to upgrade in each of the repos, and we can make pretty accurate assessments planning the upgrades for Python, Django, or another tool which is being or another package needs to be updated across our organization. For example, if there is any security patch that comes up as a version. For example, Django release security patches. So we need to identify if all of the packages have that latest patch implemented or not. Then we can just move a new alert dashboard from our tool to find out if all of the repos have been updated or not. So going through the components of our tool. The tool that we built is basically just a list of checks that are being utilized by the GitHub action workflows, jobs, and then those all of the results of those checks are being saved as YAML files, and then those are passed on to the dashboards. So for the checks, let's begin with the checks first. Sorry. So the checks are basically just some Python checks that we have implemented in our GitHub repo, and a list of checks is being added on as soon as we identify that there is a need to identify some new information in our repo that could be potentially helpful for us. We add a new check for that in our repo. For example, if we need to identify if repo was updated recently or not, if package has been upgraded to the latest Python version or not. And especially we found one of the examples that I have in mind is we need to identify the size of the repos to ensure that no extra files are being pushed in the repo, or so that was one of the checks that we implemented. And there are other examples as well that Usama will go later on, and then in the demo as well. So all of these checks are basically being used via workflows. The workflow that we have implemented for that runs once a day for all of the organization. But it does is basically creates a list of all the repositories under an organization. For now it runs on the edX organization. And then it runs the checks on all the repos one by one. So at the end we have a comprehensive list of all the repos, all the repos and the results of all the repos are being stored in YAML file for now. So we chose the YAML file because it's pretty easy to manipulate and perform the analysis on the check output. So we have the YAML file available. We convert them for now. We convert them to the CSV format and the SQL format, so that we can use those in our dashboards or in the final reports for now. So the CSV report that I mentioned is basically just a Google sheet we have for now that is being created by joining the YAML file that we have. We have a job that basically runs on a daily basis, and it converts all the YAML files and pushes the updated CSV file to our Google sheet that we use for tracking the packages. There can be some third-party tools as well that we tried on. For example, was one of the tools that we tried. One of the third-party tools that we tried to implement. And we wanted to identify if there is a better solution instead of just applying the queries or filters in the CSV. In the Google spreadsheet, we could convert to the any third-party tool that could be available for the community. So we tried the Streamlit tool, especially. And the database was tried as well. So that's one of the solution that can be that's one of the tools that can be used to identify view the data or apply filters on the data for our use cases. So benefits that we got after using this tool and building this tool for our internal usage. We first of all back when we hadn't have this tool available, we used to update all the repos when we had to traverse. We had to check all the GitHub repositories manually one by one, identify if there is any version upgrade needed or not. But utilizing the CSV dashboard, we could identify the number of repositories that need to be updated. So the assessment and the planning part on our board is pretty similar for that. And the import maintain security. So basically we got the latest updates from all the packages in which of the security packages are being updated. We have a security patch coming. Like I mentioned previously, we have a security patch, or we have regarding some specific package that needs to be updated. We can identify in a single attack instead of going to the GitHub search and compiling the list manually every time. Real world examples include our Python upgrades where we have utilized this tool in planning in the Python 3.8 and in the Python 3.12 upgrades. Along with that, we are utilizing this in Django 3.2 and Django 4.2 as well. And margin of our manual work each time is reduced a lot in each successive attempt, because we tend to go more towards automation instead of doing that reprocessing manually. For example, in the latest Python 3.12 upgrade, we didn't need to do anything manually. We just wrote a list of the repositories that needed to be updated for Python 3.12 support, and we passed on that list to a job that we had to be run on all the repos, and created the PRs for all the repos. We just need to review them and merge the PRs. So that's one of the benefit that we got by using this tool, that pre-processing time and our manual effort was reduced a lot. And especially for the quality checks as well, we can easily identify if all the repos are utilized or not, or if the latest file version is utilized or not. So we have in our dashboard we have a list of dependencies against each repository. So each we have Python dependencies listed down, so we can easily identify which version is being, if there is any specific tool, for example Pilot or Python, then we can identify the latest version being used or not. That is one of the reasons that we are presenting this solution to you guys as well. So we have made some efforts to provide this for the community as well. So it could be easily used for that. So just like I mentioned, the Python Django upgrade is the real example that we have on our edX projects that utilize this tool, and we could get the insights from the tool, and then utilize those to plan and complete our migration of our Django upgrades within the supposed timeline without any issues. Now, for how to utilize this tool, I'll pass this on to Sovan so he can go through this. Once again, if you have any questions or concern, I will be able to answer those, but someone can easily answer all of your questions. So, thanks a lot.
Okay, good evening. So I will continue from here. So my co-speaker Usama has explained the use cases and the benefit of Repo Health Dashboard, of having a dashboard for organization. So it is a solution we are currently using for around 3 to 4 or more than that, maybe 5 years. We are using internally in edX into you. So why we are presenting it here now? We recently made a change in this tool, which motivated us to present it in the Open edX conference. We made a change. Previously it was written. The workflow was written in Jenkins, an outdated technology for us, because it's quite. It was quite difficult to manage Jenkins server. So we were moving everything on the Jenkins server to GitHub Actions. So this was also the case with this workflow. We moved it to the GitHub Actions, and the benefit to moving it to the GitHub Action is that anybody, any organization deploying Open edX can set it up for themselves, because the GitHub Actions have reusability. We have tried to define a pretty generic script, so any organization can, using that script, providing the inputs, can set it up for themselves. So that's why we are here. Also, I would like to take you through the implementation, deep dive through the implementation. So before implementing for your organization, you have enough domain knowledge of the tool. So there on the screen, there are 4 repositories. The code for this is currently residing: PyTest Repo Health, edX Repo Health, and Repo Health Data, and .github repository. So I will go through the individual repository to explain about it. So yeah. So initially, it's a PyTest plugin in a repository PyTest Repo Health. So basically, what we did, we used PyTest. PyTest is used to run test. PyTest is used to collect and discover the unit test defined in the code and run iteratively. So we use this and we through a plugin called PyTest Repo Health, we modified it, and instead of discovering tests, it discovers checks. So it discovers them, runs one iteratively, and in the end dumps all the data into a YML file. So this plugin gives us flexibility to run checks using PyTest. Also provides a fixture through which we store data in a dictionary. Like running the checks individually, in the end of a check code, we store the data in the dictionary provided by the fixture, and in the end of run, it dumps the data into a YML file. Also, this plugin gives us a set of decorator for defining checks. It helps in writing metadata of the checks. So we can compile a list of metadata of the checks, that which check is doing what. It's like a short description about the checks. And also recently we made a change to it. It now supports creating multiple dashboard, because we were using, as I told you, we were using edX Repo Health Dashboard for quite a time, and we found a use case that we can have a new dashboard, that's dependency dashboard. Like we have hundreds of repository, and each repository has Python dependencies, and we had a use case that we wanted to check which each of our dependency is compatible, have a compatible license for open source. So what we did is we compiled the list of the dependencies and created a dependency dashboard. So with the help of a decorator that you are seeing at the bottom of the screen, PyTest mark, we are using PyTest markers. With this you can mark whether this check to run in Repo Health Dashboard or the dependency Health Dashboard, or you can use the same check for multiple dashboards. So this was a recent change. Moving forward, that's checks and scripts are stored in edX Repo Health. These are the repositories in Open edX organization and public repositories. So this repository is the home of all the checks we currently have, and the scripts to create dashboards from individual YML files. So checks are a Python function. The checks are run iteratively on a repository. So in that Python function, we have access to the repository and the code. So we can by analyzing the code, by going through the GitHub object, we can do anything to that repository and conclude from that and add to the result. Also, I have told you it hosts the script to convert YML files to the CSV and SQLite files. And in the bottom of screen, there is a good guide about how to add a new checks, because checks is a very domain intensive thing. So there is a proper guide written about how to adding a new check to the system. Moving forward, so this is the check function. On top of that, there is a health metadata decorator, which you can see module dict key. It is basically a dictionary key, which further has the key has ecosystem. And this check, what this check is doing is checking the dependabot YML file and checking whether this repository has the GitHub action, pip, npm ecosystems in the dependabot YML. there was a use case. We wanted to have dependabot set for GitHub action versions. All the reusable GitHub actions we had in the organization, we wanted to have a dependabot setup for that to upgrade versions automatically. So we wrote a check that it checks whether the dependabot file has the sections. By this check, we can filter out which repos don't have, and then we can add dependabot YML file and add the particular subsections to that dependabot file. So on top of the screen, the health metadata, the keys GitHub action, pip and npm. These are the keys for YML and CSV file, and on the right of that, the values. These are the metadata of checks, a short description through which we can generate a list of checks and their metadata, their descriptions. Also, this is the code written in the check. You can see all results coming as a fixture, and dependabot YML also coming as a fixture. So we write fixture. We can use the dependabot YML file. We don't rewrite the code for reading the file, and we create a fixture and create multiple checks using that fixture. And in the end of in the bottom of the screen, you can see all results dictionary being updated. So this is the required part. We have to update the dictionary, store the result in that dictionary, and on the end of check runs, this dictionary is squashed this dictionary is stored into YML file and then squashed later into the CSV file. So this is the YML file. This is a sample YML file. It's not the entire file because I couldn't fit it into the screen. It was a big YML file. So this is how the dictionary then converted and stored into YML file. So there can be a question, why are we storing data into YML files? Because for visualizing within 2U, we use Google Sheets, which our workflow gives us a CSV, and we feed that CSV to Google Sheet. So we are storing YML file as well, because we can create CSV from that. We can create SQLite files from that. By using YML, we can extend that, because suppose we find a good solution for visualizing data that have filters, that have fancy things, so we can visualize data in a better way. So we have all data in a raw format in YML, and we can convert into any format and feed that to a visualizing system. Okay, moving forward. This is the reusable workflow I was talking about. This is openedx.github repository. So what it does, it fetches the whatever organization given to him, given to this script. It fetches all repositories from that organization and run checks on all repos iteratively, and then store the YML file, store the data in the YML files, and then compile the CSV and SQLite dashboards. Also push the latest data to the data repository. I will talk on data repository on the later slide. Previously, this all thing was being done on Jenkins, and now GitHub Actions. So that's a URL. And now moving to the inputs. These are the inputs and the secrets of the current reusable workflow. So what we do is create a bot account, and we can provide email and token of the bot account to the secrets. What are the good with the secrets of GitHub Action is that when it fetches secret from the GitHub settings, and it doesn't show or reveal the secrets during the action run. So whenever whichever organization passes this thing to the secret, it won't reveal on the action run. And there is a Google credits file which is specific to the 2U, because we are using Google Sheet. And read the docs API key is for one of the checks that is running the read the docs API. And the inputs dashboard name, as I told you earlier, we have multiple dashboards now, Repo Health Dashboard and Python dependencies dashboard. We are planning to add NPM dependencies dashboard as well. So that's why I added the dashboard name and organization names. So this is the part where if you are creating setting this up for your organization, you can provide organization name and it will fetch repositories from that organization and run checks on that. And the Repo Health branch, this was added because whenever we want to create a new check, we want to before merging the code and releasing the new version of the Repo Health, we run from the branch. Running from the branch is like it won't update the Google Sheet, it won't update the CSV, it will just give us the CSV in GitHub artifacts, so we can download and analyze whether our branch is working fine. And then only check this repository. This input is if you want to check single repository, if you want to run all checks on a single repository. All these three checks, these three inputs, Repo Health branch, check this repository, and report date. Whenever anything provided to this, it won't update the main CSV. It will just give the CSV in GitHub artifacts. GitHub artifacts are the artifacts on the GitHub action run. So we can download and analyze, and it won't affect the master version. So also the report date is a cool thing, which we got a use case for. Jeremy Bowman asked us to create this. It was a use case that we wanted to check the health of our organization on a particular date. So it's a cool feature in GitHub that if you provide a date, it will fetch check out all the repositories, check out the code on that particular date. So it supports multiple years, so we can provide a date to it. It will create a health dashboard according to the state all the organization was on that date. So also it won't update the master version. It will just give us a CSV in artifact and health spreadsheet URL and worksheet ID. That's for Google Sheets and target repo to store reports. Yeah, this will be used by anyone setting up for its own organization. This is the target repository. The structure of the target repository I will tell you later in the later on slide. This repository will store YML and CSVs created by the script. And repos to ignore is also input. If there are some repos in organization which are for administration purpose or dummy repos, so we can provide a list in the input to ignore those repos. Moving forward, I wanted to demo the live version. So this is what we use for visualizing the health data. This is creating a CSV. I have filtered on few repositories. So this is how it creates the data. And what Usama was earlier discussing in the use case section, we can do this here. Like if we want to check which version of Django, which repos are using with Django 4.2. So these are the it filters the repositories which are using Django 4.2. Also we have a check like say which repository have makefile dot upgrade. So as you are familiar in edX and OpenEdX, we have upgrade make requirement. Make upgrade target, which recompiles all the txt file from in file. So it gives us the visualization of which repositories have the make upgrade target set up. So these checks helps us whenever we have a ticket we are following an OAuth, a repository is following an OAuth or not, a repository has upgrade function or not, a repository has tests defined or not, a repository has dependabot alerts set up or not, a repository, what is the size of the repository, and all the things that are in this dashboard. So we use Google Sheets to visualize that. Okay, moving forward. Okay, so this is the whole purpose of this talk, that you can now set up your own health dashboard for your own organization. These are the steps which you need to take. Create a repo to store health data. You need to create your own repo. We have a repo that's private to you. Because that contain and it is recommended to keep your repo private, because that might contain the security information as well, licensing information as well, also the potential security threats. It might contain all those, so it's recommended to keep that repo private. Also, in that repo, create the workflow which I was explaining earlier. You can create the workflow and just call that reusable workflow with the adjusted arguments, and decide the user interface to visualize the data. We have Google Sheets. We also have, as Usama was discussing, we have Metabase where we can visualize using SQLite. So it's up to the organization which tool they want. To Google Sheets is quite easy, because our script provides us a CSV, and we can just feed the CSV to Google Sheets. More detail in this link. This is a ticket for Exim to set up their own Repo Health Dashboard. Exim improvements team that has the ticket on their board. So on that ticket there is a detailed comment how to create an own Repo Health Dashboard. Also, it contains a workflow that is calling the reusable workflow. Okay, so this is the structure of the data repository. It should contain these three directories: .github and dashboards and individual repo data with the organization name, because this is how our current script is set up to output the data. And in the individual repo data on the bottom screen, it creates YML. If your organization have 100 repos, it will create the 100 YML files here, and it will updating it daily, or the frequency you set. And in the workflow section, there is a Repo Health job. This workflow that was being mentioned in the comment will give you that workflow. You can adjust it to your organization. Came to the conclusion slide. So recapping the key takeaways, that this is a tool that empowers efficient OpenEdX development and maintenance. So helps a lot in maintaining and keeping the dashboard, keeping the organization in healthy state. Offers multiple ways to visualize health data. Helps prioritize tasks and make data driven decision. Like we found a security issue in a specific release of a specific package. So we previously used to go to GitHub search to check which repositories are using this package. So now using the dashboard, we can just search that which repositories are using this package with this specific version. So we have a list. Then we can upgrade or constrain that package, so we won't be affected by the security release. So this is one of the benefits. So for the next steps, any organization running OpenEdX can set this up for themselves. Also, contributions are welcomed. Contribution in which way? We currently using Google Sheets. So if someone comes up with an awesome tool for visualizing data, maybe in a React, a custom tool in a React, using React, or maybe some third-party tool by feeding the data to that. So that will be welcome. And this is kudos to all the contributors. This is Avas, Diana, Fenel, Javeria, Jeremy, Majinder, myself, Robert, Tim, Usama, and Zubair. These are my colleagues at 2U edX that helped us in creating this all tool, and also helps in maintaining this. And that's it. Thank you. And time for questions if someone has any.
So you mentioned getting all of the output into a private repository,
Yeah.
mostly from security concerns and so forth. I was wondering if you had any thoughts on ways to create versions of these scripts that can output stuff that wouldn't be a security risk, to be able to have something that's just open for the community at all times.
We can create 2 copies, which one with the internal data and one with the public. This is what we can extend, and we can also just filter out the CSV and output that to a different repo or different branch, so that can be a public Google Sheet URL, so community can use that. Yeah, we can do that. Thank you. Any other questions?
Is it possible to convert it to kind of a GitHub action kind of thing? This whole process, basically.
Yeah, it is a GitHub action.
No.
Sorry.
There's a reusable things that you can import into workflows.
Yeah. Sorry,
Sorry
I
if I
couldn't.
missed it. I guess I missed it.
I think what he's trying to say is, like these are workflows which are defined in as GitHub workflows. He's asking, like, can it be something that you can just import out of the box? Like when you go, let's say, run a GitHub action called checkout at version 2, it does the part where it runs git commands to check it out and do all of those things, right? So similarly, can you run something like Repo Health at V2 and I don't have to do anything other than like provide its whatever inputs or whatnot in the workflow file, and it does all of these things for me automatically.
So what I'm understanding from your question is that is this related to the Brian's question about the data making it public? Sorry.
So I think I'm probably missing the right terminology here. What he's trying to ask is each GitHub workflow consists of multiple actions, and sometimes there are complex actions which does multiple things for you. So what he's trying to ask is this possible? Is it possible to convert this workflow, the Repo Health workflow, into a single action that any organization can simply use it directly instead of having to copy the YML files of the entire workflow over and over again?
It is actually a single work converted into a reusable action. Let me show you from that link. From that slide, yeah. So, this is a single reusable action. You just you can check from here. Let me. This is a reusable workflow. It is using the reusable workflow. The setting up thing is because it outputs YML files, it outputs CSV files. So we need some sort of structure, some repo to output those things, those files to that repo. So this is setting. This is giving the arguments what I explained earlier. We can provide organization name and everything. It is just a single line of thing, but with some inputs and secrets.
Yeah, that answers my question.
Thank you.
So you mentioned the X improvements team at some point.
Yeah.
Does this mean we're getting a Repo Health Dashboard for like public use?
Yep. This is basically a ticket on Exim improvements board. to collect and publish repo health data for all public repositories. This is in the backlog for EXIM improvements team led by Finil. So also this is team from Ubisoft. We plan to help them to set up their this public instance. This will also because currently this reusable workflow is only being used by 2U. Once they will set a public instance, this will also give us any difficulty we faced, we might need to have some changes in the reusable workflow or anything. So we will guide them, help them to set up a public version, and then it will be more readily usable for any organization, any community organization, so they can use, because we will have gone through the steps once, and it will be easier for others.
Thank you.
Thank you.
So initially when I saw the title of the talk before I came in, I was thinking about code static analysis and code health. Obviously it meant repo health, but my brain read it as code health, and yeah. I was thinking about all of those things. Has that ever come up, or is that been discussed, or any plans regarding those kind of health analysis for the code base itself instead of just the repositories? Just curious, that's all.
Just for explanation of your question, can you just give me an example which kind of health of code base?
So there are, like, I think static analysis and typing analysis. Like it goes through the code base and the tool reports, like of the 10 functions you have, like 8 of them have proper typing and 2 doesn't. So that's a metric that people track, and things like that. So basically like static code analysis.
Yeah, as I discussed earlier, this the check iterates through the code of the repository. So we have access of the of the code in the check. So we can do that using this. We can analyze the code. We can even run the script as we have a check which goes to the repository and hit the repo, read the docs API and check whether it has the valid URL of that. There is a check which goes through the README file and iterate all the URLs in the README files and hit them one by one and check whether the URLs are good or the bad URL, because sometimes a URL can be updated on the server, so it might have 400 return. So it goes through the README file and collect all the URLs and then check their status and then reports that this repo has all the good URLs in the README file. So basically we can do anything because we are in the code. We also have the Git object. We can check the branches. We can count the number of branches. We can do everything using that. So this is very extensible, and we also. We can create custom checks. You can add a check and not add that decorator. It won't be run in any other organization's health checks. You can add your organization customs check and mark it. So it will be run only by your organization. So it is extensible. I think that's it.
Another question? We have time for questions.
We have 4 minutes if someone.
Okay, I think that's all. Thank you, Soban, for your talk, and thank you, everyone.